All right, so we're going to finish up unit circle trig. And yesterday we looked at how to find the trig functions of the 30, the 45, and the 60. Now we're going to do multiples. Okay, so any number that's a multiple of 30, 45, or 60, we can do on the unit circle. We're still using the same triangles. The only thing that's going to be different is they're going to be reflected into other quadrants. Okay, just to make sure we remember, what is the coordinate for 30 degrees? Yep.
Square root of 3 over 2, 1/2.
Yep. Root 3 over 2, 1/2. How about, let's do the 60.
1/2 square root of 3 over 2.
So that's 1/2 root 3 over 2. And the 45.
Square root of 2 over 2, square root of 2 over 2.
Yeah. So we're still going to be using those same three coordinates. The difference is if you are in another quadrant, you might not always be, you could still be in the first quadrant. But if you're not, one of these numbers or both of them become negative. Okay? That's the only difference. And the last thing we'll look at is what happens if you have an angle that's not a multiple of 30 or 45, like that. How do you find something that's like 18? When we get to that, I'm going to show you how you type it in on the calculator. So anything that's not a multiple of 30 or 45, we're going to use the calculator. All right, let's try this one. Okay, find the 6 trig functions of 135. So if it asks for the trig functions, remember we always do it as an exact answer. And we'll do the first one with all 6. And then after that, I'm only going to ask you for 1. Okay, because that's how it's going to be on the test. I'll give you 1 trig function to find, not all 6. All right, so the first thing we want to do is make a sketch, because what is it we need to figure out? Like,
coordinate.
Yeah, we got to get the coordinate. We can't do anything till we know that. When we find the coordinate, it's either going to be the 45-45 triangle or the 30-60. It's always going to be one of those two. Let's figure out which one it is. 180, 90, 0, 270. All right. So, yeah, it's in between 90 and 180. Is it right in the middle, closer to 90, or closer to 180? Where's 135?
180. In between 90 and 180?
Yep, can you be more specific?
Like, in the middle?
It's right in the middle, yeah. 90 is 45 degrees away from 135, and 180 is also 45 degrees away. So it's exactly in the middle. Because it landed exactly in the middle, that should tell us whether that's the 45-45 or the 30-60. Which triangle is that?
45, 45.
When it lands right in the middle, it's the 45-45. And we just said that each side is root 2 over 2. So that's root 2 over 2. That's root 2 over 2. Now, what's different is we are in quadrant 2.
So one of them is negative?
So when you write the coordinate, we got to make sure if something's supposed to be negative, we make it a negative. So what's going to be my coordinate, taking into account I went left and up?
Negative square root 2 over 2, and then square root 2 over 2.
Yep. That negative right there, that's the only difference. Now everything else is, we do it the same way. All right. So let's start with the sine. Okay. What's going to be the sine of 135?
Square root 2 over 2.
Square root 2 over 2. Okay. What about the cosine?
Negative square root 2 over 2.
Yeah, it's the x value, which is negative root 2 over 2. And how about the tangent?
Negative 2 over, square root of 2 over 2 divided by negative square root of 2 over 2.
Yeah, so we're going to divide these two things. And what do you get if you divide root 2 over 2 by negative root 2 over 2?
Negative 1.
Yeah, you're dividing numbers that are opposites. Okay, so we get -1. Okay, while we're looking at the tangent, let's do the cotangent. If you flip -1, what do you get?
One. Wait, I don't remember.
What do you get if you flip -1?
0 over 1.
You can only get a 0 if you had a 0 to start with somewhere. There's no 0 in there.
Oh,
Would
1
it be
over
one?
-1.
It's -1 over 1.
So it'd be 1.
So when you flip that,
It's -1.
it's -1. You can't flip a number and have it change from positive to negative. When you flip a number, you just have this. That's still one, it's still a positive divided by a negative. And a positive divided by a negative is always a negative. Right? Where you put the negative doesn't really matter. Okay? So any question why it stayed the same? Okay. How about the cosecant? Which trig function do we flip?
X.
Well,
No,
what's the
y.
name of the trig function? It's the y, which
Y.
is
Negative square root of 2 over 2.
sine. Yeah, flip the sign. So take the sign, which is root 2 over 2, and flip it. Does anyone remember what we get?
2 over square root of 2, but you have to fix it.
So yeah, you get 2 over the square root of 2 to start.
Equal to.
To square root of 2.
It just turns into the square root of 2. Because when
Why
you
do you have to multiply?
well, when you multiply the top and the bottom,
Yeah.
that gives you 2 root 2. And then the bottom is the square root of 4, which is 2.
Alright.
And then
Okay.
those cancel. So now you're just left with square root of 2. All right, and how about the secant of 135 degrees?
It's just going to be
This
negative square root of 2.
Negative square root of 2. Yep. Since the only difference between the sine and cosine is one's positive and one's negative, that's the only difference between the cosecant and secant. One's positive, one's negative. And that's the 6 trig functions for 135. Any question on that? Okay, let's try this one. This time we are not finding all 6. We're only going to do one of them, just the cosecant. All right, they've given us the cosecant of pi over 4. What do we need to figure out first?
coordinate.
Yep, we have to figure out the coordinate. If you want to change that to degrees to do that, that's fine. If you know the coordinate without changing to degrees, that's fine too. Okay. Does anybody remember what that is in degrees? Pi over 4?
45 degrees.
That's 45 degrees, yep. So 45 degrees.
That would make the coordinates square root of 2 over 2, square root of 2 over 2.
Yep, so it's this, something we did yesterday. Okay, so square root of 2 over 2, square root of 2 over 2. Both sides are root 2 over 2, because it's a 45, 45. And we are in quadrant 1, so they are both positive. Root 2 over 2, root 2 over 2. And how do we get cosecant? We flip what?
Y.
Flip the y.
So wouldn't it be just be square root of 2?
It'd just be square root of 2. Okay. Any question on that one?
The 30, 60, 90, what was the coordinate for 30, 60, 90 once again?
So we're going to go through them, but those are your two coordinates for the 30 and the 60.
Well, I know the 45, 45, 90 is the square root of 2 over 2, right?
Yeah.
And then
What's-
the other ones are 1/2 and like the square root of 3 over 2, but they're flipped for whichever one
Okay.
they are.
Never mind, thank you.
Okay, so that's 135. We did 45. All right, let's try 225. Okay. First thing we always got to find
Coordinate.
the coordinate. We got to figure out where it is. Okay, so make a circle. Label it. And figure out where 225 is. First, let's just figure out it's between what two?
180, 270.
Okay, so we know it's somewhere between 180 and 270. Now you got to be a little more specific.
Is it in the middle?
Yeah, is it in the middle, closer to 180, or closer to 270?
I would say it's in the middle.
Yeah, it's going to be right, it's right in the middle. If you're not sure, then use your calculator to find the difference between 180 and 225 and 225 and 270. You'll see it's 45 away from both. Okay, so here's 225. Make your triangle. It's what?
45, 45.
A 45, 45, so each side is what
Square
number?
root 2 over 2.
Both through
But
2 over 2.
Aren't they both negatives?
But when we write the coordinate, yeah, we have to take into account we went left and down. Okay? So here, I'm just labeling how long this side is and how long that side is. We're going to put a negative with it to indicate the direction. All right, so negative root 2 over 2, negative root 2 over 2, and they want the sign, which
It
would
be
be?
negative square root 2 over 2.
Yep, so negative square root 2 over 2. Okay, and we can check it. The calculator won't give us the same answer as a fraction like that, but it will give us a decimal, which we can use to check. So if we take the sine,
Whoa, what's all that?
don't worry, I'll show you. If you take the sine of 225, you get that number. Let's compare that to what we got. Negative root 2 over 2. Negative root 2 over 2. How does our answer compare to what the calculator said?
They're pretty similar.
Yeah, they're the same thing. Okay? So that's not an acceptable answer to write down. Okay? You have to write it down as negative root 2 over 2. But you can check it the way I just showed you. Yeah?
Why is that not acceptable? Just because that's what it's asking for, or like is that actually like there's a reason?
It's not exact.
Yeah, on the test, it's going to say find the exact answer. So I could add that to all these directions, but yeah, it'll say evaluate exact. So I'm doing it the way it'll ask you to on the test. Okay, so that's 225, and let's try this one. Cosine 7 pi over 4. Okay. All right.
We gotta convert it to degrees maybe, unless I know what that is, but I don't.
Okay, so yeah, converting to degrees is probably a good idea. So that's 7 pi over 4. Okay, well, start with just this. What's pi over 4?
45.
So it's 45 with a 7 in front.
What? What? How do you?
Because we just,
45 from where?
That's the last, what would be
our
2
second
problems ago?
problem we did pi over 4, and that was 45.
But why wouldn't you just convert it to degrees?
I am.
But that's not being smart.
Well, I'm kind of doing a shortcut because I know this is 45 from 2 problems ago. So it's just 45 times 7.
But okay,
So
I don't
yeah.
get it. But
So
I don't think I will get it.
4.
So if you want to do
That's
it,
45. But
Hey,
how
can we
is-
do it the normal way?
45 times 7.
so to do it the long way, multiply by 180, divide by pi, pi's cancel,
I get that. Yeah.
and then 4 goes into 180.
Yeah.
How many times?
No idea. I would need a calculator.
45.
45. Now you
How
have
many times
7
by 7?
times 45.
See, I just can't put that together
Yeah.
without doing that.
So it ends up being exactly the same thing I just did, 45 times 7. It's just it's a few more steps. But you can do it that way. That's fine. Okay. So it's 315. Okay. So now we're going to label our circle. Okay. When I start to get to an angle that's that big, instead of labeling this 0, I label it 360. It's the same thing as 0.
Is it in the middle? No. Is it by the 270 side?
So yeah, closer to here, or right in the middle.
Is it closer to 270? Or in the middle?
Is it in the middle?
Yeah, it's right in the middle. Because if
Okay.
you add 45 to that,
Yeah.
you get 315. And then if you add 45 again,
So it'd be 45, 45, so the square root of 2 over 2 is square root of 2 over 2, but
So-
there's a negative in front of one of them.
yep, we got to make sure we put the negative in the right spot.
This one's positive, negative, or?
Positive because we went right, yep. And then negative because we went down. So that is the coordinate for 315. And now they want the cosine. Since they're different, if you mix them up, it's going to be a problem. What's the cosine of 315?
Square root of 2 over 2.
It's the x value, square root 2 over 2. There you go. So now we've done a 45 in every quadrant.
I have a question.
We did all of these.
What, like, number, like square root of 2 over 2, what is that representing? Like the function? I know it's like the function, but what is it? Like,
The number.
well, I know it's just a number, but what is it? It's not an angle, it's not a length, it's...
No, it's not. It's a number without any label. It's basically, if you want to think of it in terms of a triangle,
Yeah.
it's the length of one side of the triangle
Yeah.
divided by the length of the other side of the triangle.
What does that, like, tell you, though?
So what it's going to allow us to do later on is how to figure out this angle if we don't know it. As long as you know how long these two sides are, you can figure out how big that angle is. But that's not what we're doing in
Ever?
this week.
Ever? Ever?
This week.
Ever?
Yeah, this week.
Ever?
Yeah.
Got it.
And the reason it doesn't have a label is because if you think of like this side, pretend this is like 2 feet,
Mm-hmm.
and this side is 3 feet.
Yep.
When you divide feet by feet, it's kind of like when we did those units that cancel out. So all you're left with is just a pure number with no label at all.
Yeah, I just didn't know what it, like, was.
It really represents the length of two sides in a triangle divided.
Okay.
Yeah. I will do
So
more.
how are
of
there
it.
different ones?
What's that?
So, like, sine, what is that one representing? Or
So
just-
each trig function is two different sides.
Okay.
Sine is like
How
this
do you
side,
get 6 of them?
and well, you have 3 options,
Yep.
and you can pick 2 of them in any order you want.
Oh,
So
I
3
get it.
times 2 is 6. That's why there's 6 trig functions. You got this one and this one, or that one and that one.
Mhm.
You got that one and that one, or that one and that one. All the different combinations. Yep. That's why there's 6.
Okay.
All right, so let's try tangent of 120. Oops. Okay, so now we're going to figure out where 120 is. Right in the middle, closer to 90, or closer to 180?
Closer to
Closer to
90.
90.
Yeah, this one is closer to 90. It's how far past 90 is it? 30. So this is 120, which means it's 30 degrees past 90. So this section right here is 30. This is 30. How much is this part on the inside?
60.
60.
60. And then how much
Why
is,
is it 60?
30, 60, 90.
Oh,
and how much is the top?
30.
30. So you've got your 30, 60, 90 triangle. In the 30, 60, 90, remember you got the short and the long. What's the length of the short side?
1/2.
It's always the 1/2. And what's the length of the long side?
Square root of 3 over 2.
Square root of 3 over 2.
Stay proud.
Now, we're in quadrant 2. So how would you write the coordinate?
Negative, wait. Yeah, negative, positive.
Negative,
positive.
positive. Yep. Okay, so now we've got the coordinate. If you got that far, you get half credit because you at least knew the coordinate. And now for full credit, you got to tell me the tangent of 120. How do we figure out tangent?
You divide the two.
In which order?
Y over x.
Y divided by x. And when you divide them, what's going to happen?
The 2's cancel out.
2's cancel out.
So it'd be the negative square root of 3.
Yep. Okay, when you divide 2 fractions and the denominators are the same, you don't really even have to flip and multiply. You can just cross the denominators out.
How does the negative move from the bottom to the top?
When you have a negative in a fraction, it doesn't really matter.
It's the whole fraction that's negative,
if you put it like that, or like that, or even if you put it like that. Top, bottom, right in the middle, it's all the same. Okay. Any questions on tangent of 120?
No.
Okay. Let's try secant of 690. Okay, what's harder about that angle?
It's past 360, so.
Past
So you
360.
So you're gonna
subtract,
have to, yeah.
subtract 360.
Okay, so take 690, subtract 360,
You're probably gonna have to, oh, okay.
we get 330. So that's good. We get something between 0 and 360.
And that's closer to the 360 side.
270.
That's gonna be like 3/4 of the way there.
Yeah, so 330.
Oh, no, a third of the way.
It's definitely closer to 360. So I would put it like that.
Yeah.
Okay, so 330. Draw your triangle. This way, this way. Okay, that's the long side, which is how long?
60. Not 30.
So that's root 3 over 2. Here's the short side. How much is that? That's a half.
Wait, how do we know that's 30, 60, 90?
Because what's the distance, well, what's the difference between 330 and 360? 30. That's how you,
So 30,
so
69.
because it's a 30. So here's your 30 over here. Here's your 60 right there. There's your 90.
And it would be positive, negative.
Yep, and this time because you're in quadrant 4, the coordinate is positive because you went right, negative because you went down.
So if it's 30, then that one's always 60 though?
If one's 30, the other one's always 60.
Okay.
In a right triangle,
Yeah.
has to be.
Does it matter which side is 30 and which, well,
Yes.
I mean, visibly you can see.
but like,
Yeah, if you draw it, if you switch the two numbers, it comes out wrong.
how so? Because the short side's always going to be 1/2 and then,
Well, like if you had the 300, that would be down here. That would switch the x and the y when you draw your triangle. Now the short side is a half, so the half would come
the
first.
short side's always 1/2 though.
Right, but the short side can either go left and right, or it can go up and down.
Oh, I got it.
If it goes left and right, it goes here. If it goes up and down, it goes there. So it makes a difference where it is. Okay. So we got root 3 over 2, negative a half. How do we find secant?
It's the reciprocal of x.
Reciprocal of
Cosine.
cosine, which is the x. So that's,
2 over square root of 3.
so we can start with that. And then how about when we
Times it
fix
by the
it?
square root of 3.
And when you times it by root 3 over 3, you get?
2 square root of 3 over 3.
Good. 2 root 3 over 3. Okay. Any question on that one? Okay, so we're not going to go through like the 45s. We did all of them because there's only 4. But with the 30 and the 60, there's 2, 2, 2, and 2. So we're not doing all of them.
Are we gonna get any like questions on the test that like ask about what specific quadrant?
No, it's not really going to ask the quadrant. It's going to ask the coordinate.
Okay, because I have no idea.
Yeah, the quadrants are just like that. All right. So what do we want to do first here?
Make it degrees.
Make it degrees. How much? Again, this is how I would think of it. How much is pi over 6?
No idea.
Isn't that 30 degrees?
That's 30. So that part is 30.
So you times it by negative 7.
So you times it by negative 7. What's 30 times negative 7? Yep. So it's negative 210. Okay. If you don't want to do it that way, you can do the 180 over pi, but that's what you'll get. Okay, so we got it in degrees. That's good.
Now we put it in to get a point.
Still something else I would do with it before we try to put it on the circle.
Subtract or add 360.
We should add 360 so we don't have to deal with a negative angle. So take negative 210, add 360, and that is 150.
How does that not change the answer though?
By adding a revolution?
Because it's going back to the same
Yeah.
spot.
So like, all we're doing is instead of thinking about going this way, that's not accurate, but for this problem. But instead of thinking about going this way to get to it, we're thinking about going this way. Still end up at the same spot.
Okay.
Yeah. Now let's draw that accurately for this problem. Okay, so we got 180 and 90. Where's 150? Closer to 90? Closer to 180? Right in the middle.
Closer to 180. It's 30 degrees away from
It's only 30 degrees away from 180. So let's put 150 right about there. Okay, make your triangle. Okay, so we've got long side, short side. What's the long side?
Square root of 3 over 2.
Square root of 3 over 2.
And
Short
then
side?
1/2.
1/2. Now when you write the coordinate, make sure we
Include the negative.
include the negative. So what's the coordinate?
Negative is positive.
Negative
3/2.
3 over 2 and positive 1/2. Okay, how do you find cosecant?
It's the opposite of your y.
It's the what of the y?
Reciprocal.
Reciprocal.
So it'd be 2.
That would be, in this case, 2. Yep. This would be 2. Okay, any question on that one? All right, so now I'm going to show you a diagram, but it's going to have basically all the different triangles that we've done. There's the 30s. There's the 60s. And, you know, I'm not going to draw them all, but then you could also draw the 45s then. So there's basically 3 triangles in every quadrant. The 30, 45, and the 60. So that would look like that. So all the red triangles, those are all the root 2 over 2s. The only difference is sometimes they're negative, sometimes they're positive. That's the only thing that changes. All the green triangles, those are the 30s. Root 3 over 2, 1/2. The only difference is sometimes it's a negative in front of one or in front of both. The blue triangles, those are all the 60s. The 1/2, comma, root 3 over 2. So as long as you know those 3 coordinates, all the other ones are just mirror images. And then these we did the very first day. Those are the easy coordinates because there's no square roots in them. All right, so that gives us a total of 3 in every quadrant. So there's 12, and then 13, 14, 15, 16. So the way we've learned it, there's 16 different angles that we can do on this circle. And notice this shows it pretty good. They're not equally spaced. You're missing one, like right there, and you're missing one right there. There's like an extra big gap. That's because those are the 15s. Just
Did
not.
you ever learn that?
No,
I think
no, we don't learn the 15s. We could though.
No thanks. I didn't say that.
All right. So any questions on that whole diagram? It's everything we did. It's all degrees and it has radians. Now you might get an angle that's not on that circle, like you get negative 200 something. Well, if you add 360, then it'll be on the circle. So you'll always get one that's on the circle, unless I tell you to use the calculator, then you could get anything.
Can I take a picture of that?
Take a picture? Yeah, yeah, you can go ahead. It'll be on YouTube too.
Okay.
Yeah. All right, so that diagram is great as long as you have the angle that's a multiple of a 30 or a 45. But what if we don't have an angle that's a multiple of 30 or 45? Okay, so for that, we need to use the calculator. All right, so it's pretty straightforward, but you do have to know how to change something on the calculator when you type it in. So let's start with this one. Okay, so first of all, when you see an angle that's not a multiple of 30 or 45, you're going to see that symbol, which means
It means, like, not exactly.
Equivalent.
yeah, it means it's approximate. Okay, none of these are exact answers. Okay, so that's a difference. All we have to do to put this in is take your calculator. First, can somebody read that to me? What does it say?
Sine of 18 degrees.
Sine of 18, the last word was very important, degrees. We know it's degrees because it has the circle. When you type it in on your calculator, you need to make sure you're in degrees. Okay, the calculator can do degrees or radians. To check or to change the mode that you're in, if you press mode at the top, you'll see at the fourth row down, two choices, radians and degrees. If you want to do a problem in radians, put it on radians, you hit enter. It'll always tell you right at the top what mode you're in. No matter what, most screens that you're in, you always see that at the top. Okay? So you always know. All right, so I want to be in degrees. The directions in the problem are not going to say change your calculator to radians or degrees. You just have to look for that. If you see it, degrees. If you don't, radians. All right, and now we just type it in. So when you put that one in, you should get 0.309. All right, so you can try it. If you're not getting 0.309, something's wrong with your calculator, or you're not putting in the right number.
Wait, Hager, how did you change the mode again?
You press the mode button. It's right up at the top in the second column. Do you find it?
No.
So it's right, it's the very top button in the second column
Oh, okay.
on the main keypad. Okay, so that's sine of 18 degrees. All right. How would we read off that one?
Cosine of 356 degrees.
356 degrees, so it's still degrees. So I'm going to keep it in degrees. Put that in. And when we hit enter, what do we get for the cosine of 356 degrees?
0.99756.
Okay, let's go to 3 decimal places. So we would have 0.998. Yep. 0.998. If you notice, that number is getting pretty close to what?
1.
It's getting pretty close to 1. And if you go a little higher, cosine 358 gets a little closer. Now it's 0.999. Cosine 359, it's even closer, 0.9998. When you get to 360, now you've hit 1. If you go past 360, it starts coming back down again. So it's like it gets to the highest it ever gets is 1, and then it comes back down. Right? And that's because if you look at your unit circle, cosine is which letter?
X.
The x. What's the farthest to the right you can go and still be on this circle?
1.
The farthest you can go is right over there, 360, which is the same as 0. Yep. And what's the farthest to the left that you could go on the circle? The farthest left is -1. So anytime that you're trying to take the cosine of something, it's always going to be between -1 and +1. You can't go past those two numbers. Same thing with the sine. The highest you can go is 1. The lowest is -1. And then you can get every value in between. All right. Let's try tangent. Anyone think they could tell me how I'm going to do that one? Yeah?
You change your calculator to radians and then type in tangent 2.4.
Yeah. How do we know to change it?
There's no degree symbol.
There's no degree symbol. Okay. So if you don't see that degree symbol, change it to radians, type it in. And if you're trying it, you should have gotten negative 0.916. Now with tangent, I told you sine and cosine have to stay between -1 and 1. That's not true with tangent. With tangent, you can get other numbers besides -1 to 1. In fact, you can get really big numbers. Oh, that's not that big. But if I type in, let me type it in a little different. Tangent of 89.999. That's a very big number. Okay, so yeah, tangent definitely, that's what I wanted to show you the first time. Tangent does not stay between -1 and 1. So what did we get originally? Negative 0.916. Any question on typing those three in?
No.
Okay. So then how about that one? The cosecant of 247 degrees. What do I need to make sure of first?
It's in degrees.
Yeah, I already changed back to degrees, so that's good. Now, how am I going to get cosecant? Well, how have we been doing cosecant all week?
Don't you square one of them?
No, we haven't done any squaring, but how have we been getting the cosecant normally?
Flipping the sign.
Flipping the sign. That's exactly what you have to do here. You have to flip the sign. So do 1 divided by the sine of 247. That's how you do the cosecant. Take the sine and flip it.
Is that the same for cotangent?
Yep, we'll do one of each. This one's negative 1.086. Now, some people remember from algebra, if you raise something to the -1 power, that flips it. So they see this button right here, and they think, oh, the sign with a -1, that doesn't work at all. Okay, it does something, but it's not what we want right here. So don't.
That's what I meant. I was asking if we could second it, not square it.
Oh, yeah. So yeah, don't use any of these 3 blue ones. That's inverse sine. That's next week.
Oh, yeah.
Okay?
What does it do?
So you can type it in that way, or you could type it in. You could say, all right, just give me the sine of 247, and then you could say 1 divided by the last answer that I just had on the screen. That's more steps, but you will get the same thing. Okay, it's negative 1.086.
Cool, yeah.
All right, let's try that one. Okay, how would I put that one in?
1 divided by the cosine of 6. Oh, like in radians.
Right, in radians. If I type it in like that, it will give me an answer.
I still don't understand why it would
That's
be.
wrong.
I still don't understand why it would be 1 divided by.
Well, that means to flip it.
How is 1 divided by?
So like, if you have the number 3, right?
Yeah.
And then you do 1 divided by, that's that number flipped.
Okay, thank you.
Yeah. So 1 divided by just means to flip it. Okay, so I said if you type it in, everything's typed in correct, is typed in the right way, but that answer is wrong.
It's in degrees.
It's in
not
degrees.
radians.
Okay, so it's not like you're going to get some kind of error warning you weren't in the right mode. It's just going to give you whatever number it's going to give you. If you press second and enter, you can bring up the last thing you typed in. So that is definitely a different answer, 1.041. All right, and the cotangent. All right. How am I going to type in
You have to
cotangent of
switch it to
13?
degrees first, and then you do 1 divided by tangent 13, 13.
Yep, so we can do 1 divided by tangent. It's not the only way, again, I showed you a different way, but that's how I do it. Okay, so the cotangent is 4.331.
So how do you can get like those big numbers with tangent and cotangent?
The reason why is because, let me show you a picture real quick. Look at sine and look at cosine. Okay, we haven't looked at the graphs yet, but we are going to eventually. That's cosine. That's sine. How high and low does it look like each one of them go, up and down?
1,
Yeah, the highest it goes is 1, and what's the lowest?
1. Wait, what?
Negative 1.
Oh,
So the highest the graph goes is 1, so it's always under that, and the lowest it goes is negative 1. It always stays between those two lines. Now look at tangent. Let's add that one in. Does it look like tangent is stopping at 1 and negative 1 and staying between them? No. Tangent goes up forever and it goes down forever. It just keeps going because there's an asymptote in the graph. That's why. So sine and cosine are nice connected graphs when you draw them. Never have to lift your pencil the whole time you're drawing it. But tangent, it's these sections that kind of repeat and look like that. And because you have to lift your pencil each time, you have an asymptote, and that's what causes it to go up as high as you want to go. And as low as you want to go, too. So if I type in something like tangent of 90.00001, look at the answer I get. It's like negative 5 million something. It's really, really far down. Right? It's basically negative infinity. What do you think would happen if I try to do exactly 90? So we did 90.001. Here's 89.999. That's the opposite. It's like positive 5 million. What if I put it right on 90?
would you get like 1?
If you put it right on 90, you can't do it. Okay, you can't put it right on 90. Tangent of 90 doesn't exist.
Why?
Because, think about, good question. Think about 90 degrees. Where is it on the circle?
Top.
Top. What's the coordinate right at the top?
0.
0,
Oh, it's undefined.
1, and tangent is y divided by x. You just tried to divide by 0. Can't do that. That's why it's undefined. So there's a lot of connections between the picture and the unit circle. If you start to understand it, it makes more sense when you put the two pieces together. All right, so any questions on how to type in any of the 6 trig functions on the calculator? All right. So that is the homework for tonight. So 49 to 57 odd, 67 to 81. You need a calculator for all of those. Okay, it's a calculator. Okay, so you got about 20, just about 20 minutes. Okay, so you can use the time to try to get some of that done. Reminder, if you have class tomorrow, we'll do a review. Go over the homework, then we'll do the review. If we don't have class, the review will be extra credit if you want to do it. We'll go over the homework on Friday, and then we'll have our test on Friday. So either way, we're done all the material for the week.